Okay, so let's get into this. We're looking at the NTI RACMUX-D17HR-N. I mean, that name is a mouthful, right?
It really is. It sounds more like something off a starship
Yeah.
than a piece of IT gear.
Exactly. But our mission here is to really unpack it, to figure out what a KVM drawer actually is and, why these specs matter so much.
And it really starts with the basics. KVM is just keyboard, video, mouse. This whole thing is basically an entire workstation that fits into a tiny slide-out drawer.
How tiny are we talking?
We're talking 1 RU, so for anyone not living in a server room, that's about 1.75 inches high. It's an incredible amount of consolidation.
Okay, so one of the first things that jumps out at me is that HR in the model name.
High resolution.
Right, high resolution. So why would you need a 1920 by 1200 resolution screen on a drawer in a server rack? That seems a bit like overkill.
It does, but it's all about productivity. With that much screen real estate, an admin can, have 2 dense management windows open side by side. No scrolling, no shuffling windows around.
That's a huge deal in a crisis.
A huge deal. And the visual quality is better, too. This model has an 800-to-1 contrast ratio compared to the standard 500-to-1. In a dim data center, that difference is critical.
And it's physically flexible. The screen tilts up to 120 degrees, which I guess helps avoid that server aisle neck cramp we all know.
Yeah, but the real flexibility is on the inside, with the connectivity. It has to be.
It's like a bridge between different generations of hardware.
It absolutely is. I mean, nobody has a server room that's all one type of machine. This connects to modern DVI and USB computers, but also to legacy PS2 machines.
So you can manage a brand new Linux server and then turn around and work on, an old Solaris or even a Mac OS 9 machine.
From the exact same spot. It's that universal control that's so important.
Okay, that brings me to the industrial design side of this. We hear rugged thrown around a lot. What does it actually mean here? I'm curious about these torque friction hinges.
Those are sort of the unsung heroes of the design. They're what keep the monitor from wobbling or slamming shut when you move it. It's just a sign of how well it's built. The whole thing is rugged steel with a powder coat finish.
And it locks in place when you pull it out.
It does, yeah. The drawer locks open so it's stable while you're typing. No sliding around.
And it seems like they really thought about installation. It's adjustable for different rack depths, from 24 inches all the way out to 40 inches.
Right, it's meant to be pretty universal.
Right.
But the most telling feature, I think, is the power option.
The 24-volt one.
Exactly. The optional model that takes 18 to 36 volts DC. That's not for your standard data center running on AC power.
That's for a telecom environment.
That's telecom or utilities or industrial sites. Places that run on 24-volt DC battery systems because power failure just is not an option.
That's a really good point. And before we wrap, I have to mention the little user-friendly touches like the security lock and the USB port right on the front.
For a flash drive or something.
Yeah, just right where you need it.
So when you pull it all together, what you have is this masterclass in specialized engineering. It solves the space problem, it solves the old versus new hardware problem, and it's built to survive in places a normal computer wouldn't.
Built tough for tough places. And that leads to a final thought for you to take away. Given its rugged construction and that very specific 24-volt power option, what does this tell us about those critical, non-standard environments? Think about telecom towers or factory floors where IT gear has to run perfectly far away from a clean, climate-controlled office. It makes you think about the hidden infrastructure that really relies on hardware built just like this.